Now, wherever there are people, there is cancer. And this is despite billions and billions spent yearly on cancer research. Even if you have access to all the resources in the world, many types of cancer still today are death sentences. Senator John McCain was recently diagnosed with glioblastoma, and even he had to say, "I understand." Now, this is a key reason why cancer is such a difficult disease to beat. You can represent the tumor as a tree. The leaves are the fast-dividing cells that we're all familiar with, and they make the bulk of the tumor. The stem are the cancer stem cells that generate the leaves. Current therapies, such as chemo and radio, kill fast-dividing cells. They're designed to do that. So that kills the leaves. But the cancer stem cells are left behind because they're slow-dividing, just like the stem of a tree. So then they're able to just grow back into the new space, regenerate the whole tumor. This is recurrence, and that's what kills most of the patients who lose the battle. So we need to kill the cancer stem cells, but we're only learning how they work, and they have a trick up their sleeve. Now, typically, a drug blocks the molecular mechanism that tells the cell to divide. But when you do that to a cancer stem cell, it just switches over to using an alternative, very special molecular mechanism that now gives it the command to divide and regenerate. It is this special mechanism that is doing so much damage to so many patients. And it is why current treatments don't kill the stem cells. Innate repair scientists discovered this special mechanism, and this is it in a more scientific form. This is all our own work. And it has enabled us to find ways to attack the stem cells and kill them. Our work has been recognized widely by the scientific community over the last couple of decades, and it has allowed us to identify 40 specific compounds that kill the stem cells. 7 of them are already approved by the FDA, which means they're safe, they're in the market, they're actually in the pharmacy down the road. But they're not used for cancer. We want to repurpose them for cancer, and we could use them as is. Another 30 are also approved, and we want to repurpose them, but we would need to change the way we deliver them to the patient. And then we have another 3. We're very excited. These are new to the world, highly targeted, and very powerful. Now, these ones up here are more simple to validate and bring to the patient, and the ones at the bottom offer additional potential for more patents in the future. But we have already protected our foundational intellectual property. We actually submitted our latest patent application just a couple of weeks ago. So we cover the use of these compounds in oncology, biomarkers, and the method that we use to discover them. We have validated our core science principles and the key treatments, and we know that the mechanism operates in vivo. The treatments show great efficacy in vitro in preclinical testing, and we even have some clinical validation evidence. Of course, we're not the only ones who are trying to do something good in oncology, but innate repair has some attributes that I think they're very special and they make us stand out. First and foremost, we're dealing with a completely novel mechanism, which, by the way, we discovered, and there is great untapped potential here. And we can target the cancer stem cell, which has been extremely elusive. And we have a range of low-risk compounds that we're working on. And we have fantastic researchers and great support from academia and industry. Innate repair is at the process of spinning out from the University of Dresden. This is one of the centers of excellence in Germany, and they are shareholders, so we're very, very happy about that. The co-founders, the core founders, are experienced, and to add to our business and management expertise, we are partnering with Future Health, a very successful European biobank that are entering the therapeutic field. And we have great advisors that will help us go to the clinic and go to the market. Some of these people are co-pioneers with us. We've been working together for many years, publishing and patenting together to get innate repair to where we are today, ready to commercialize on groups of compounds. And this is how we're going to do it. Our product is intellectual property, and we will perform specific validation de-risking experiments that is going to increase the value of our products by a lot. The numbers, these are indicative figures based on published market data to give you an idea of the scope of such ventures. We're currently focusing on the first year, and we ask for 2 million so that we can perform the preclinical validation, and at that point we will open new opportunities such as licensing or selling our intellectual property to big pharma, obviously partnerships with them, exit strategy potentially, or we might go ahead with the next phase of validation, which is the clinical validation. So investment support is going to enable us to commercialize on a group of compounds based on a completely new science, and it will also help us provide new options, new therapeutic options to patients who have a disease which is both devastating and currently incurable. Thank you very much.